Hi again, and here's the chapter 2 of decimals. So in the previous chapter, we were talking about the decimal itself, how are the real world applications, like some kind of groceries, when you just some kind of talking about the sports, talking about anything. So it means that we are using decimals a lot without knowing it. So we talked about a couple of definitions about the place value system, that each one of those digits, if we put it at the specific point, what do they actually mean. After I talked about adding and subtracting of decimal, and we are here so far. So the reason that I put it in another video is that multiplication and division are going to be a little bit challenging. Again, they're following every rule that we know about the whole numbers, yet I believe it would be better to consider it in a separate video. And also at the end of this part, we are going to solve a couple of questions. Hope you like it. Okay, without further ado, let's talk about it. So let's talk about the multiplication. What does it actually mean when we're talking about we are trying to multiply two decimal numbers? So the very first thing that I'm telling you is that try to make everything simple. What does that mean? It means that when you have two numbers, two whole numbers, just assume that you have two whole numbers. One is 24, another one is 55. So the way that you do it is simple. You use one of those digits from the second number and multiply by each of those numbers, and again move to the next one by knowing the fact that actually the second number is going to outrank the previous one, so you have to consider a zero. By the way, I'll put the link on the top in order to some kind of, if you have any problem about the multiplication of some kind of numbers. We had a couple of videos about that, so you can check it and don't worry. We do have the same scenario right here, but with one small difference. So I'm thinking it would be better to consider that small difference at the end, and we come back again to the thing that we had, because obviously I'm trying to use your knowledge from the multiplication that we have about the whole numbers and somehow align it with what? With the multiplication of decimals. Right now we do have a question. What is happening at this question? I do have two numbers, 38.639 multiplied by 2.08. The very first thing that I'm telling you, that imagine that none of these points are exist. It means that we don't have any point, we don't have any point. And just do it as the way it is. It means that obviously we know how we can multiply three digits by some kind of five digits, two digits by two digits, anything. Just imagine there is no decimal point. So what would happen at that time? It's easy. So let's do it. I do have 38. Again, there is no point. 38,639 multiplied by 208. I'm doing that. So what is happening at this point? Obviously, you all know that one. 8 multiplied by 9, it would be 72. We are going to keep the 2 because I told you that in each unit we only can consider a number between 0 and 9. Put a 7 as a carrying number to another part. We do have 8 multiplied by 3 plus 7. And after that, we do have 5 as the point that we can put it for the next side, and so on and so forth. So for the first part, or for the unit section, I do have this number. Maybe some of you would ask, okay, why the thing just happened? If you guys watch the video about the multiplication of whole numbers, you don't have any problem with that, but just in case. So why do you think I do have two zeros right now? If you remember, I told you that it doesn't matter if we're talking about the whole number or decimal numbers. Each of those digits, based on the place that actually they're there, they do have some kind of string, they do have some values. It means that at this point, when you're talking about, for example, about the 208, the value of 8 is not the same as the value of 2. Actually, each number in the 2 or in the hundreds actually worth hundreds, while each number in units actually worth 1. So at this point, I just skipped one step. What does that mean? Because in the most of the scenarios that we know, I have to, after I had my 8, I have to move to the second number by knowing the fact that I also have to multiply the final answer by 10. Why is that? Because every number that exists over here actually worth 10. So I'm going to do that, right? But here's the thing. So I know 0 multiplied by any number is just 0. So it doesn't make any sense if I want to do that. Rather, I'm just putting so many zeros. So what else? What's the point? That's why I skipped this part. After that, we move to the next part, which is 2. Again, remember, there is no point at this place. So, I mean, the point was the decimal point at this place. So just forget about that. Let's look at 2. We know that 2 has the value of 100. So whatever number that we find from the multiplication of 2 by this big one has to consider another 2 zeros beside of that. That's why we do have 2 zeros over here. So it means that at the beginning of the point, we just put 2 zeros. They are going to be considered at the first place and second place. And actually, our multiplication would be started from the third place. Again, if you have a problem with that, I do have a full video on the multiplication. You can check it. Again, it's not that kind of challenging, but yet you have to be careful because it's a very commonplace. I've seen so many times that students, they had a problem with this specific point, because at the end, if you forget to do that, your whole answer is going to be changed. Okay, based on the fact that we know 2 zeros should be here on the right side, let's just do the multiplication. I do have a 2 multiplied by 9 is 18, and I will consider my 8, and after that move the 1 as a carrying number to the next side, which is number 3. I do have the 2 multiplied by 3, again I have to add it with 1, and so on and so forth. We are going to do the steps until we do have the full number and the multiplication is done. So far I do have 2 numbers, the first one and the second one. Again, adding, right? When we're talking about the multiplication of more than 1 digit by more than another 1 digit, we have to consider this fact that we are going to have multiple row of numbers, and based on the column that we put for all of them, as we can see over here, I do have 2 in the same column with 0. I do have, let me just change it to this one. I do have 5 with the same column, 8 with this 9, 8, 6 and 7, 0 and 2, same as this one, and at this point we don't have anything, so we consider as a 0. So based on that, we have to do the adding, right? So at the end, I do have this big number. So if you remember, I told you that there's a small difference between the decimals and the whole number. We know the fact that decimals has one important difference with the whole number. Decimals, rather than just a full number, rather than the whole number itself, they do have another number that is going to be between 0 and 1 beside themselves. So at this point, what do I have? I do have 38.639, 2.08. Let's just count how many decimal points do we have. So at this point, I do have 3 decimals. At this point, I do have 2 decimals. Add those numbers, not by numbers themselves. I mean, add and count it, and adding the number of counts. I do have 2 decimal points. I do have 3 decimal points. If I add those, it would be 5. Keep this value. Let's look at the answer. The answer is big number without knowing. Right now, the point is there, but right now we don't know how. Start from the right number. Start from the units and move to the top. 1, 2, 3, 4, and 5. What is 5? 5 was the accumulation of all of those decimal points that I had because of the first number and second number. Right now, I'm going to use it. Why? Because I know because of my first number, I do have 3 decimal points. So I have to move 3 decimal points to the left. Because of the second number, I do have 2 decimal points. So I have to move 2 from the right itself. By adding these 2, I had 3 steps. I have to add another 2 steps, and I do have 5 steps. I put this point or decimal point after the 5th number, counting from the right, and I do have an answer. So right now, my answer, instead of being as 8,034,752, just convert it to 80.3475 and 2. Okay, so this is the philosophy about multiplication of decimal numbers. Again, try to make everything simplified. Try to use the way that you know. Obviously, one of you would say that, okay, it would be a little bit easier if you consider the decimal point at the beginning. Yes, that is completely right. But again, at this point, I'm just trying to help you to understand the questions. Imagine that you're doing it in one of your exam or would be part of indirect thing, and you're trying to do that. Yes, I know using the calculators and all the kind of AI is going to help you a lot. But the thing is that we are going to do it by ourselves. So simplify it again, number of steps. Don't consider any decimal points at the beginning. Do it like the way that you know, based on the whole numbers, find answers, count the number of decimals for the first one, the number of decimals for the second one, add them up and use it as a last number. For the last number, count from the right, start from 0 and move it to whatever number you have, put a decimal point and you have the final answer. Easy. So let's talk about division. Actually, for some of you that are looking for the steps, you can just look at this part, but I thought it would be better to just explain because again, in this channel, I'm trying to help you some kind of understand it better. Yes, you also can read that. There are so many textbooks there that you can use it in order to find the division. But let's just go straight to the question itself. So you all know about division, right? We talked about it, how we can use the division. For instance, when I'm talking about the 100 divided by 7, I can use the 7 as this point. After that, I do have this symbol, and I do have 100 itself, and you know the way. We would start from the first number that is going to be some kind of the equal or bigger than the number that we are going to divide that, and after that, so on and so forth. So at this point, there must be some differences, right? Because we're talking about decimal points. So let me just give you a hint. First of all, let's read the question. What is the question? The question asks to find the division of 123.573 by 137.4. So here's the thing that we can some kind of, first of all, we know that everything would be division. I mean, when I'm asking you about this question, actually I'm asking about the remainder, and I'm asking about the number that we are going to consider as what? They do have some kind of names. I mean, you can just find all of these names over here. The number that we are going to be divided, we are going to divide it, that you're going to use it and inside the division box. And after that, a number that it's going to be in the place or become the whole number, we all call it as divisor. So we are going to consider these two numbers, right? And after that, we do have another point as a remainder, which we know about. So far we do have dividend, divisor, and we do have a remainder itself. So in order to help you a little bit and to familiarize with all of those terms, I mean, either you can use it or not, it doesn't matter, okay? You can remember them, you can memorize them, but as long as you know the way that you can divide a number, which is going to be a big number, divided by another number, has a remainder, and it also has some numbers on the other side, you're good. But if you insist, you can remember them. So the number that actually we are going to divide it onto another number, or this is something that we call as a dividend. The number that is going to be resemble that as the number that we are going to divide it based on that is the divisor. And the number that we find, and based on that, for instance, when I'm talking about 10 divided by 2, at this point I do have 5. 5 is going to be number of times that this 2 is repeated inside the 10. 5 is something that we call as a quotient. And after that, whatever left is something that we call as a remainder. So have it this one in your mind, and after that we are going to do the decimal by decimal. Okay. So based on this fact, I do have two numbers right now. I do have one number that is going to be smaller than another number, and I'm going to do the division. First of all, for sure, we know this number or the quotient is going to be smaller than 1. A number between 0 and 1. How I know that? If you remember from our previous slides and previous some kind of video YouTubes about the fractions, we were talking about proper and improper fraction. What was the improper fraction? Improper fraction was the one that its numerator was bigger than that denominator. On another hand, proper fraction was the one that its numerator was smaller than denominator. So for instance, we call 2 over 3 as a proper fraction. So right now, this proper fraction is a number between 0 and 1. If you just do this calculation, 2 divided by 3, you can just find it, 0.6666, you can see that there's a number. And this number is between 0 and 1. Try anything you want. As long as your numerator is smaller than your denominator, you have a number between 0 and 1. So for sure, we know at the end, the answer of this question or the quotient of this one could be and should be a number between 0 and 1, right? This is the first fact. Another thing that I'm going to tell you is about the steps that how we can do this division. So I do have a big number. I do have 123.573 divided by 137.4. The one step that I'm telling you is that it would be better to, again, simplify everything. What is the most problem we do have problem with? The most problem that we have a problem is the divisor itself. So we are trying to keep it as a whole number. It means that somehow I have to get rid of the point without changing the question. Let me give you a simple example. Imagine that I do have 2 divided by 3, right? After that, I'm telling you, based on the rule that we know, whatever number that you have and you multiply by 1, the number would be itself. You remember about reducing to the least common denominator and common denominator. Again, you can see the link on the top. So on that point, we have to multiply the numerator and denominator into something in order to do the add and subtraction, right? I'm going to use the same scenario over here. How? Are you guys agree with me that 1 is equals 10 over 10? It doesn't matter what kind of number I'm using. As long as those numbers are the same, they are going to be 1. 10 divided by 10 is 1, right? So at this point, would it be okay if I say that I'm going to multiply these two numbers by 10? Why I can do that? Because in another hand, I'm doing this. 10 divided by 10 is just 1, right? So what would happen if I do this? It would be 20 divided by 30. I didn't change anything. The only thing that I'm doing right now, I'm trying to have bigger numbers. Again, try the calculator. 20 divided by 30 is just 0.666. Let's go back to the question itself. I told you that I don't like the form of my divisor and somehow I have to fix it. It means that I don't like this point. So I'm going to multiply my dividend, the one that I'm going to divide another number based on that, and also divisor by 10. It means that I'm moving this decimal point to the right side. In the meantime, I'm going to move one decimal point to the right side. Nothing has changed. because as we know, the 3.5 multiplied by 10 is equals to 35. Again, if you have a problem with that, imagine that this guy is the multiplication of two whole number. 35 times 10 is 350, right? But I told you, count the number of decimal points that you have for your first and second one, add them up, and after that use it for the last number. How many decimal points we have in total? Exactly, it is just one. So I have to move my point to this value, and after that, since the decimal point is on the left side of the zero, zero doesn't count, and I only have 35, right? That's why we do have it. So at this point, I'm just moving 1 point from the left to the right. Easy, right? Okay, let's do the division. If you remember, I told you for the division in this specific form, I have to find a number that is going to be equal or bigger than the divisor itself. Why I'm doing that? Because I'm trying to find a solid number that see that how many times that specific thing is repeated in itself, right? So at this point, what do I have? At this point, if I start from the beginning, I do have what? I do have 1,203.35, right? But probably this number is not going to be bigger than 1374, right? So I have to find a way in order to fix this issue. How am I going to fix this issue? By using another number beside, right? If you remember, I told you that when your number is not big enough, you have to borrow a number, not borrow a number actually, move that specific number on the right and consider it as your number. But here's the thing. Right now I can see that I move the decimal point to the right, but I still do have that decimal point. So the thing that I'm telling you is that right now we are only putting our focus on the quotient, divider, and divisor. Dividend and divisor, okay? Let's not focus on the remainder itself. Again, try to consider everything as whole number by whole number. Why am I trying to do that? Because by this way, I can simplify everything. Look at this point. So I do have 1235. Again, it's not bigger than 1374. I have to borrow a number from the right side, put it in this place, and after that, I can do that. So what would happen if I consider 7, but I think that actually there's no decimal point? It's going to have some consequences for me later, especially about the remainder, but let me give you that one consequence right now, because I'm going to simplify everything, yet I'm not going to lose that point. At this point, when I'm getting rid of this decimal point for this part, I'm going to move it to the top. I'm going to consider it for the quotient. It means that after that, you remember, right? For the quotient was the number that is showing to me that how many times is actually the number that I choose from the divider is going to, dividend is going to be, I'm going to count how many times the divisor is going to be repeated inside the specific part of the dividend that I chose, right? So right now I know that 1, 2, 3, 5, 7, again, I moved the decimal point to the top. I will talk about it. Right now I want to know how many times 1374, again, I know I moved the decimal points to the right, so there is no decimal point at all. How many times have been that guy is repeated? If you just use the calculator, we just use the thing, you see that there are 8 times that 1374 is repeated inside that specific point. So obviously it's not going to be a perfect value. I do have some remainder, right? We are going to use that. So 8 should be written as your first quotient, but you see that I had the decimal point? Decimal point is going to be on the left side of your first quotient. And at the end, it's going to be there, and whatever number that we have, we are going to keep that point, and we are going to talk about the final answer. Okay, let's look at it. From now on, everything is just like the way that we have about the whole over whole, okay? So I do have this big number. I had it as this one. I had this big number, and right now I'm going to subtract the smaller number out of it. Is that so? So if I do this subtraction, what do I have? I do have, obviously, you know better than me about the subtraction, but again, you can find it in this YouTube channel. I talk about all of the subtractions and all the things that we do have from the borrowing method. You don't have any problem with that. So at the end, the final answer or the remainder is going to be 1365. Again, I do have a problem. This number is not bigger than 1374. So I have to borrow another number out of it, move it to the right side. I do have this number, right? Right now I have to see that how many times 1374 is repeated inside this number. If you do the calculation, that number is going to be 9. So I will keep the 9 as a quotient just beside the 8 itself. So do this subtraction, and I do have this number. Here's the fun part. Right now, if you just do your calculation, for instance, let me give an example. Again, 2 divided by 3. You have different options. What is that option? You can write it as that this number, or this number, right? So maybe some of you would say that, okay, probably those numbers are the same. I'd say that no. At this specific point, the numbers are the same, but imagine that your answer has different decimal numbers. So in the question specifically, they would mention most of the time that if they're looking for a division, and if they're looking for answer, by the way, when they're looking for the answer, 99% of the time they're looking for the quotient, because the remainder is not that hard, you can find it easily, but it's the quotient. They would tell you until how many digits you have to continue. These number of digits are going to show how accurate your answer is. So obviously I can say that the answer is 0.8, right? It is good, but still it's not accurate. So 89, 0.89 is better. Another 9 would be better, or any other numbers. So this is a part of the question, and the question would tell you till how many digits you have to continue your division in order to reach that. So let's move to this part. Let's see why I do have a 0 from another side. Here's the fact. We are still working with decimal points, right? Yes, I told you that, imagine that's a whole number, but we are still working with decimal points. Do you remember from the last video I told you 1.5, 1.50, and 1.500 are the same? So it doesn't matter how many number of zeros you're using actually. At the end, both of the and all of those three are the same. So at this point, at the very beginning of the question, I knew that I'm going to face this issue. That's why I consider more zeros for myself. Why I'm trying to do that? If you look at this question, that I do have 1287 as my remainder. If I don't have those two zeros, actually I'm going to stop. So 0.89 is my final answer, which is the correct one. But the question already asks you to continue it for 4 digits. It means that I have to find a way in order to continue this work. How am I going to do that? Use number of zeros. Yeah, I know some of you would say that, okay, in the matter of whole numbers are going to change everything. Remember, we're still working with decimals. Yes, somehow we got rid of points by moving to a quotient, but we're still working with zeros, and we still can use them. Why? Because it doesn't matter how many times you put a 0 after the last number in your decimal point. You're still not going to change anything, okay? So I'm considering the 0 as one of my aidings in order to continue the work. If I consider my 0, I have to move it to the bottom, right? So again, I'm back on track. I do have 12,870. So I have to see that how many times 1374 is repeated inside of that, right? So if you do the calculation, again, you have the 9 itself. Since I still have to move on and I still have to continue, another 0 would be added on, and so on and so forth. So the final answer would be this. The remainder at this point is completely dependent on the number of zeros that you consider for the work itself. What does that mean? If you can see over here, I consider 2 more zeros for my work. Is that so? But the final answer seems like a whole number. It's simple. How many number of zeros you consider for your work? Are you cheated? So 2. Just move the decimal points 2 points from the right. 9.18 is going to be your remainder. What did we do over here? Again, try to pause the video, try to think about it, try to rewatch the video. If you didn't understand it again, I would be more than happy to help you just putting some comments for me, and I will solve more questions. So the thing is that from the multiplication and division, both of them, we were trying to simplify everything. For the multiplication, we were trying to do that by getting rid of all of those decimal points at the beginning. From the division, we are trying to, again, move the points in a way that our divisor is going to have the simple form. Also, we did a couple of more steps using the zeros, move the decimal points from the dividend to the quotient itself. So it's just a matter of steps. It's just a matter of training for you to completely understand what is happening over here. Again, try to look at the whole video at this point, especially about division, because multiplication, I believe it wasn't that kind of challenging, but division is important. Try to look at it. For the next chapter, I'm going to solve different kind of questions from the addition, subtraction, division, and multiplication to make sure that you guys are on track.